So that's the first evaluation method I wanted to describe, this idea of looking at precision and recall on recovering constituents. But I want to look at a second type of evaluation, which is based on accuracy in recovering what are called dependencies. And this can actually be a very useful way of getting some insight into how accurate a parser is and what constructions it's doing well on and what constructions it's not doing so well on. So let me again take this tree, the man saw the dog with a telescope. This could be a gold standard tree, or it could be the output from a lexicalized PCFG parser. And again, we see that the non-terminals are all lexicalized. And the key idea is going to be that we can convert a tree to a set of dependencies. And let's see how we do this. Okay, so we basically have a grammar in Chomsky normal form here. So for every binary rule, we're going to have a single dependency. Let's skip over this one for now. We'll go into the second one. So the first dependency says, basically, I should have said, this column shows the head word, and this is going to show the modifier word. Remember, our rules in this grammar are going to take the following form. XH goes to 1, Y1, H, Y2, W, or XH goes to 2, Y2, W, sorry, Y1, W, Y2 of H. Okay, so essentially you have some rule. X1 goes to Y2, for example, and I have some head word H, and I have some word W. So here I have H and W, and here I have the rule. So this first dependency here is saying that I have saw as the head, I have man as its modifier, and I have the rule S goes to NPVP, and that dependency is extracted from this rule at the top of the tree. So what this is basically saying is I have a dependency relationship between saw and man, these two words in the sentence. And we can think of this rule production as a label of the type of the dependency which is involved. This is basically signifying that we have a subject-verb dependency. This all goes back to what I showed you very early on in the parsing slides, which is that whenever I see configuration of this kind of form, I have a subject and I have a verb and I have a subject. And so now we're seeing that these dependencies reveal exactly these kind of grammatical relations. I've been slightly careful here to not just give the word involved, but also its position in the sentence. So this is 1, 2, 3, 4, 5, 6, 7, 8. So this is saw at position 3, just in case we have the same word. In fact, we do have the same word repeated multiple times. The word the is repeated multiple times. Okay, so we can convert a tree to a set of dependencies, which basically represents the critical grammatical relations within this particular parse tree. And we can again calculate precision and recall, so we can convert both our gold standard trees to these dependency representations, and we can also convert our parser output to these dependency relations, and then we can see how accurate we are in recovering these kind of dependencies. So one thing to note is the following. Actually, let's go back to the slide for a second. You'll notice that I have 1, 2, 3, 4, 5, 6, 7, 8 dependencies, and I have 1, 2, 3, 4, 5, 6, 7, 8 words. And that's always going to be the case. I'm always going to have the same number of dependencies as I do have words. Okay, so there's none of this business of different parse structures having different numbers of dependencies. What I should have said is I have this special dependency for the word at the very root of the tree. So this is saw, and I'll just specify the rule in this case to be root and the head word to be root. Okay, so to make sure that we also take account of this word at the very root of the tree. Okay, so every tree, whether from a gold standard tree or from the parser output, is going to have a number of dependencies equal to the number of words in the sentence. And so we can actually just report accuracy in terms of how accurate we are in recovering these dependencies. So to get a dependency correct, you have to get the two words in the dependency. You also have to get the label, i.e. the rule, correct as well. If we look back at the results from my PhD thesis parser, again, around 88% dependency accuracy. Okay, now one very nice property of these dependencies is that we can delve a little deeper by looking at the accuracy, or more specifically the precision and recall, in recovering different dependency types. So for example, I could look at all subject-verb dependencies. More precisely, I can look at all dependencies with this label. So whenever I see this label, I know that the dependency is involving a subject and a verb. And I can again calculate precision and recall in terms of recovering dependencies with this particular label. So the recall for subject-verb would be the number of subject-verb dependencies I have correct, divided by the number of subject-verb dependencies in the gold standard. And the precision would be the number of subject-verb dependencies I get correct out of the number of subject-verb dependencies I have in the parser's output. And notice these two numbers may not be equal because we may have different numbers of subject-verb dependencies in the two parsers, and so we go back to the idea of calculating recall and precision. The nice thing about this measure is that we can go dependency type by dependency type, and we can figure out which dependencies are recovered with high accuracy and which dependencies are actually more problematic. And here are some numbers. So, in fact, if we look at subject-verb pairs, so this is dependency of the following form, we do pretty well on these. We get over 95% recall and precision. If we look at object-verb pairs, so these are basically going to be of this type. VP1 goes to VT-NP. So whenever I see a dependency like this, I have a relationship between a verb and its object. For example, if I say the dog saw the man, I'm going to have a dependency between saw and man labeled VP1 VT-NP because man is the object of saw. And again, these are recovered with pretty high accuracy, over 92% recall and precision. If we look at other arguments to verbs, so in general you can look at all of the other productions involving verbs, so rules of this form where we can have y1 and y2. Each of these is going to have a dependency where the verb is modified in some way. Again, we perform pretty well here, about 93% recall and precision. Some problem cases, though. If we look at prepositional phrase attachments, so these are going to be rules of the following form. XH goes to Y1H PPW. So X could be in a noun phrase, or it could be a verb phrase, or any case where we have a prepositional phrase modifying something else. We see that we score low 80s in terms of recall and precision. So we can see that's a pretty stark drop from subject-verb accuracies or object-verb accuracies. And it reflects the fact that PP attachments are a challenging problem in that, in reality, to get very high accuracy, you really need full world knowledge of what is more likely semantically speaking. Am I more likely to be using a telescope to see, or am I more likely to be looking at something holding a telescope? And those kind of decisions are difficult, and that's reflected in the drop in accuracy here. If we look at coordination, so these are things like dogs in houses and cats, where cats could modify either houses or dogs. These are even lower accuracy. These are very, very difficult. So the take-home from this is, I think, that the core structure of these parsers is quite good. Basic relations like subject-verb, object-verb, other arguments to verbs are recovered with high accuracy. It's when we have modifiers by prepositional phrase attachments, coordination ambiguities, and so on. Those are the cases which are causing difficulty. These are old results. Actually, this parser, in spite of this date, was more like 1997. Although I think if you looked at modern parsers, you'd still see a similar split between easy or high accuracy dependencies and lower accuracy dependencies. So to summarize, we saw that a key weakness of PCFGs was the lack of sensitivity to lexical information. And in this lecture, I've described lexicalized PCFGs as one way of getting around this problem. Some key steps were, firstly, to lexicalize a tree bank using head rules. This allowed us to go from rules like S goes to NPVP to these lexicalized rules like S SOR goes to NP dog BP SOR. So we used this trick to vastly increase the number of non-terminals and also the number of rules in our grammar. The second step was to estimate the parameters of a lexicalized PCFG using smoothed estimation. So we have a very large number of rules of this form that poses challenges to parameter estimation, but we can use smoothed estimation techniques to come up with robust estimators for these kind of rule parameters. Finally, in terms of accuracy of these PCFGs, it's around 88% in recovering constituents or dependencies. And as we saw, the core sentential structure, core grammatical relations like subject-verb and verb-object are recovered with quite high accuracy. Cases such as prepositional phrase attachment are still fairly challenging.